Hi, everybody. My name's John Parsons. I work for Signify, which is basically Philips. So everyone's heard of Philips. Signify is part of Philips. We own many different brands, Philips being one of those, True LiFi being the other one. I work within the device integration piece for edge devices and computing using light technology to stream high-speed data with very low latency to devices. And so let's get started here. And this will give you a little bit, I don't know if audio is going to be on, but let's say, yeah, there is audio. So, who's Signify? We're the number one, we're the largest lighting company in the world. We like to say that at the end of the day, we own the ceilings in almost every business out there. So, anywhere with manufacturing, anywhere in offices, hospitals, surgical wards, it's our lighting systems. We did $7 billion last year. We have about 38,000 employees now, and we were voted as the number one industry leader within the sustainability index. And so below gives you an idea of all the different companies that we own under the Signify company. We are based in Amsterdam. So sustainability, that's one of our core areas that our management team looks at. And so when you look at this slide, we're involved in a lot of areas around greenhouses and lighting, healthcare, well-being, safety, security is one of the areas that we really work into with the LiFi. And so we're going to get into the meat of this, of how it's going to work within the XR community. So this will give you an idea. This is using beam steering technology right now that we're working on, and that will basically allow the beam to follow an individual or a computer or an edge device and supply data. Here's the problem. Every 2 years, the data is doubling. And so you have more IoT devices, you have more edge devices, you have more cell phones, tablets. All of them are using the radio frequency. And the radio frequency, I had a slide, but it was a very ugly slide, but the radio frequency spectrum is full. And so that's where you get dropouts, right? Or you get high latency. With LiFi, you don't have that problem. And so as this grows, the world is going to have to look at what can we do to keep data flowing, right? And you cannot continue to do what we're doing with radio frequencies. Wi-Fi 6, great product, it works, but it will be outgrown. And it's moving very fast as people keep buying devices and keep connecting. The average home had 3 to 4 connected devices. 2 years ago it did. This year it has 9. And they're slated in the next 2 years to have up to 50 in one house. And so they are all vying for the radio frequency to be able to get data. LiFi, what is it? So we operate in the infrared and the visible spectrum. Look at it as Morse code 4.0. I'm sending you basic light ones and zeros running very, very fast. And you cannot see it. Even with the visible light, and it would be in here on one of these lights, you couldn't tell that that is actually streaming data. It's streaming so fast. And we like to say to people, you know, the first LiFi was probably something like a, you know, this guy here using the light to communicate ship to ship. Or you were using it as a lighthouse, right? Now, what we do is that we have the LiFi where you don't have any interferences. You don't have any emissions. There's no licensing. It's just pure light being sent to the device. This is Wi-Fi. And so it gets backed up. LiFi. It's unlimited on the number of channels that we can have. And so it just streams seamlessly and at extreme speeds. Speeds right now, we're running 250 megabyte upload, download. We have tested the system for a AR glass just last week at 500. And in our labs, which will be pushed out in the next year, will be at 1 gigabyte. And we're testing 10 gigabytes per second upload, download with 1 millisecond latency. So that is the area that we're working on today. So when you look at Wi-Fi, and we don't compete with Wi-Fi. We don't want to compete with Wi-Fi. Wi-Fi has its place and it's going to stay. But the Wi-Fi user, that radio frequency goes outside of the contained area. With LiFi, it stays within a contained room. And so there's no way that you could eavesdrop or pull data or get into the system using LiFi because it's contained within a room. It is a line of sight technology. So you have to have line of sight. What are the benefits for these devices? So you are looking at a Vue6 Blade. We're running 250 megabyte upload, download. Latency on that is 1 millisecond, and it's extremely secure. It's a very secure system. And so, as you notice, you have the lights on the ceiling. Hopefully those are Philips. We connect directly into that. And if you look at the top of the person's cranium, you'll see where the receivers are. There's 2. We're adding 2 more, so we will have 4. 1 here now. 1 here, 1 here, 1 here, 1 here. So that we get the full side of this, so that we can beam light from the sides or the ceiling. We're working on technology to actually start to embed it onto floors so that if you want to use gaming, you can do that as well. Why are we entering into this market? RF in the military or RF in secure manufacturing facilities is usually not permitted, as well as in the hospitals. Schools in Europe are starting to stop Wi-Fi and putting in LiFi into the classrooms because they're concerned about health. You've got it inside of oil and gas, mining. There's about 20%, 15 to 20% of the market share today cannot be addressed due to the fact that you can't use RF. And so that field is wide open for the XR devices. because I worked at PTC before with the Vuforia product in the military, and there were many times that we could not sell any software into these companies because they wouldn't. What am I going to use it on? Am I going to haul around a computer or have it tethered or use Wi-Fi? I can't do that. True LiFi on planes. It's happening. By the end of the year, we'll have an Airbus jet with LiFi on the jet. So you'll have LiFi right above. It'll be streaming data, and you can basically then use your laptop. You can use a set of XR glasses, whatever you want to use. The reason why they're going that route is 1, interference, and 2, weight. So this is a lot more cost effective to put in a light system than it is to put in a RF Wi-Fi based system onto aircraft. As well as ships are starting to do that. It's the same thing with the trains. So as Signify Philips, we're putting lights into the train systems in Europe, as well as into, you'll see more airlines coming out with this over the next probably 12 to 18 months. And so you will be able to basically sit down with a pair of VR glasses, play video games, and have extreme high-speed data connectivity, and it will be wireless. So what's our goal? What do we want to do? My goal with working with this technology is to untether VR. I don't want to carry a backpack, and neither does anyone else. I don't want to carry a side piece. No one else does either. I want to have full connectivity. I want to be at 2 to 3, probably gigabytes, upload, download, lightweight, and it's running VR. And that's where we're going to push this into this market, because we believe that that is the future. And so I don't believe that Wi-Fi can enable that at this point in time, and I don't think that it will get there if you have multiple users on the same system. And so that gives you a little bit about what we're doing. Now, I've got a prototype at the Vuzix booth running on an M400, so you can go by and look at it. It is on their M400 series, but it also will work on their Blade and their 4000s. We've got the HoloLens 2 working on LiFi, so you have upload, download capability on a HoloLens 2. And we're working with just a couple of other XR device manufacturers in order to bring this into market. As far as us taking this and adding it onto one of your laptops, we can do that today. We have a dongle, plug it in, hits the transceiver, hits the ceiling, away you go. So that's easy to do. It's this technology here that we're working on, and it really has to do with micro beam steering, and it has to do with high speeds, and it has to do with thermals, and how we're going to develop this and untether all XR devices so that you can then have a lightweight device. And so I'm going to open it up to some questions, because I've got, 10 minutes here. See what kind of questions you have.
Thank you very much for the presentation. I wanted to ask you, have you compared the requirement in terms of power and size for your LiFi receiver compared with the Wi-Fi receivers?
The receiver on the unit itself?
Yep.
The receiver on the unit itself right now has 2 transceivers on it, and they are somewhat power hungry, right? So it's not something that if you're running this on typical AR glasses and they have a lifespan of 7 hours, you'll be at 5 with us, okay? So it's going to pull that down, but we have external battery packs. As we move forward with this technology, that is one of the areas around the battery and the life and the size of that. And that's something that the lab in Holland is working on right now, is to miniaturize that and make it more economical.
Okay, thank you very much.
You're welcome.
Can you walk us through some of the security features of LiFi versus Wi-Fi or Bluetooth?
Yes. So at the end of the day, if you just look at a radio frequency, if you switch on, and I'll use this just in different areas, if you switch on radio frequency in a battlefield or in a forward operating base, the signature's there, they pick it up and it's done. If you have radio frequency and you're in an office building, I can pull all the data off of that RF all day long, and no one will even know. With light, it's line of sight. So if I had a LiFi system in here and someone's standing outside, they cannot get any access to any of the information that is being streamed. And so that, in and of itself, so inside of a large manufacturing facility, you can be running LiFi, but if you walk outside, you're not going to get any data. The data stays within the room and it's self-contained. We're putting LiFi into submarines, we're putting LiFi into the military ships in NATO because of just this type of situation, right? You don't want RF because it's easily intercepted. Now, they have the encryption, they have all of that, but I'm a physical layer security, and then they'll add on encryption on the other end of it. But I'm giving that piece of it on the first hop. From the edge device to the access point, you can't get the information. It's unobtainable. And so that's why it makes it very secure, and that's why we're extremely busy inside of, you know, the industrial military complex, these companies that need to have very, very highly secure facilities in order to do what they're tasked to do. But it also is in oil and gas and in mining, where you cannot have RF because you would have explosives, right? So you can use light waves. I can run a light wave. The farthest we can run a light wave is 25 kilometers. So you can run a light wave down a tunnel. You can stop it there, run it down another tunnel, and you have connectivity. And then you can have the light, basically the emitters in the ceiling just strapped on, and they're going to emit a cone of light. How wide the cone of light dictates how fast the data runs. So if you had a pencil and you were going to beam that pencil around, I could run very high speed data. But in manufacturing, I don't need to have that high speed of data. I need 50, maybe 80 megabytes, consistent, pure, 1 millisecond latency. It doesn't go down. There's no drop-offs. It's just there. That cone of light can be from me to the first gentleman here. So you got a cone of light, and then I can just basically strap a ceiling with these access points, and they're cheap. Just add access points. You've got it on the headset, and away you go. The other technology is that we're researching right now is being able to charge the unit via light. So now I can follow you, I can charge it, and I can run data through it. I can also compartmentalize it so I know exactly what light beam is hitting what person and what information to give that person through our system. So if I'm working next to a person who doesn't need to know what I'm working on, I can subdivide that, and he doesn't get the information that he needs. So it's a very secure system using light. That's not the case with a radio frequency device. Shelley, did that answer your question?
It did, thank you.
Oh, you're welcome.
And more fun topics.
You said you had a tracking system, so it follows you when you're moving. How many endpoints can you have per AP?
16.
Okay, but when they're moving in different directions?
That is the devil in the details, and that's exactly what the guys in Eindhoven are working on now, is how to follow that and how to keep that beam and how to run a beam across another beam and not lose that, right? So I don't know, I'm thinking probably another 12 months, but at any time you can go and look at the lab and see what they're working on, but they're always That's a key component at the end of the day. That, sitting in an airplane, running, I don't know, 500 megabytes, 1 gigabyte down to a person, gaming, that's pretty cool, right? And then you can have that system set up on the plane. But if they're moving around and playing, it's a different story.
Also, I wanted to ask you, are you using visible light or infrared light?
Both.
Okay. So
These are infrared that I'm looking at now.
okay, does the visible light interferes with the light if, for example, you want to turn off or want to work in the dark?
Turn off the light, the data's still going.
Okay, thank you very much.
Thank you. Any other questions? I mean, the goal is you have to take these virtual reality glasses and untether them. That's where it is. You can't carry this stuff around. And you need to have that down to a really small form factor so that you can actually play games and do stuff. And you don't have to haul everything around. And it needs to be very, very energy efficient. And it needs to be able to have latencies of 1 millisecond. Latency is the key for that.
What about combining VLC?
VLC is another technology that we have. That's just a one-way VLC, so that will basically triangulate where you are within a room. We can add VLC onto this, so then I know exactly but where the device is, how the device is moving, the speed that it's moving, and then I can stream data to that person in a warehouse because I know that Joe is going down aisle 42A. He's going to get this. I'm running down another aisle. I'm going to get this. And then you can add VLC onto that. That's a pretty easy technology for us to do because we've been doing that for years, and just adding it on, it's been discussed, just no one, I think, in the lab has done it yet.
So I have one more question for you.
Yes.
It seems like there would be all kinds of use cases for this. I mean, I can see the traffic lights talking to my car or intercar. Or are there other use cases you're working towards for it?
One of the use cases for us would be anywhere where RF would be an issue, but we also, being, Philips Signify, we also put in all the light poles in New York, right? That's one of our jobs, right? So when you can then run light technology off of that, then it starts to become very interesting, right? Underwater as well, using light waves underwater to send data signals is a huge field, especially for the military within submarines and that, or ships being inshore. They can communicate underwater just running light, right? So the use cases are endless, but Wi-Fi takes care of 80% of the stuff out there, so there's no reason to get rid of Wi-Fi. You want Wi-Fi. But this is just a supplement. So when you put on the glasses, it just asks you right away, you want Wi-Fi or LiFi? LiFi, you're on.
I'm just curious, like, how easily it is to accidentally block, like, the beam or anything like that.
So if you block the beam, the data stops. Open the beam, the data starts, right? And so that is a line-of-sight technology. And so that's why we're working on either beam steering or we're working on multiple access points, not access points, but transceivers on top of the head, right? So that is an issue. You're going to have that issue really with everywhere you go. One of the use cases that we're working on with one of the airlines is, so you would walk under a light. It fills the information onto the AR device, all the work instruction for the day, and then you go about your day. Then you come back in and you upload it on through that light, and it's secure and it's done, right? So that's another use case. There's so many different use cases, but it's just, you got to pick the use cases that you want and the battles that you want within this. Because it's not the be-all, end-all of connectivity. Any other questions? Go by the Vuzix booth. Take a look at what we've got. It's the first one out. There's only one on the planet, and it's sitting over there right now. And so that will be in production. We're launching it today. That will be in production in the next few weeks. And so that, you know, that will kickstart the market. LiFi has been around a long time, but with the pandemic, it slowed us down by 2 years, right? And so we're just back at it, and during those 2 years, we've just been developing product. And, you know, I had a slide up here that just showed all kinds of equipment that we have, but then one of my marketing guys said, take it out. You know, they wouldn't understand it. So this isn't vapor hardware. It's out there, and it's in the field, and it's being tested, and it's working. So.
Can you comment on the cost aspect as well?
What?
Can you comment on the cost?
Yeah.
Cost aspect as well?
Yeah, so if you wanted to wire up an operating room, just, you know, operating room, $3,000. So you have the cable coming in, you have fiber optics coming in, we have modem access points, just go into the ceiling. They're industrialized and hardened. Pop it up, and then you have 16 ports. So you can run cables wherever you want to. If you have a large manufacturing floor, it's not prohibitively expensive to put this in. An access point of our cost is like 55 euros. And, you know, I can run multiple off of one access point. And so it's not prohibitively expensive to do that for the gain that you get for having a secure AR, VR, MR in a facility where radio frequencies are not permitted. And that's the world that we're working in now. Thank you. If you have any questions, call me. Look me up on LinkedIn. We'll be at Vuzix. So, thank you.